Great. Um, Fantastic. So, guys, just to give a quick context about where we are, one of the right for some of the newcomers, the main page to start off with, understanding more details about the CoStack is this page on the CoStack Innovation Challenge. Yeah. So this one, it's right. So if you go to uh, this thing, who is it? Uh, Anyway, right. So it's you'll find it. It's basically linked from the news and events tab over here. So this thing will help you understand all the different things, and you can go over some of these previous recordings as well. Yeah. So this link about understanding the core stack data structure will tell you how we are representing landscapes in terms of entities, landscape units in terms of entities of the form that you have water bodies. Yeah. A water body has a particular geometry and it has some properties like what is the area. It has some time series properties that in each year, how much of that water body area was under water. Yeah. And in fact, it's a seasonal time series. So we find out how much area was underwater during the monsoon. Then some of it would have dried up. So a lesser amount of area which was underwater during the post monsoon and lesser amount during the summers. Yeah. And then some other things that what is the zone of influence of this water body? That in how much area does it support cropping? Yeah. And in that zone of influence, a time series of cropping intensity. That how much area in that zone of influence of the water body is single crop, double crop, and so on, right? So that is an idea that water body is a unit, right? Similarly, this unit is inside a unit called a micro watershed, right? Micro watershed can have many water bodies. So this one similarly has an area and certain other properties linked to it. Yeah. And these micro watersheds are inside watersheds and subbasins and river basins, right? Similarly, you have a hierarchy of administrative boundaries of state, district, tehsil, village, and micro watersheds and villages intersect with each other. These ones can also contain Narega assets and so on, right? So this post will basically help you understand what is this data structure, yeah, and how is it populated. So what happens actually in all of this is that all the underlying layers that we have. So again, right, linked from all of these different things will be if you go to further links, like you go to the challenge details link over here, this opens up this page, which we'll go through in more detail today. But there are a lot of other links. So if you go to this Earth Engine application, this application lists all of these underlying data sets that, uh, right, that this is a pan-India land use land cover, that which pixels are built up or underwater or under different crops and so on, right? So ultimately, the way these data structures are populated, right, of watersheds and micro watersheds that we were talking about, the way these different units are being populated are from these kind of assets that on a particular, right, village boundary, how much area is plain, how much area is under shrub and scrub and so on, right? So that's how all of these things come up, right? So, right, so you can use some of these to understand what those underlying data sets are. Yeah. Um, then after that, we wrote a bunch of starter kits. So these starter kits are uh, just to help you understand that how can you read data, use the CoStack APIs to read data that has been pre-computed, and you can use this to do all sorts of different analysis. That this is a tehsil, and it shows you that for different micro watersheds, how much area is plain, right? So most of these micro watersheds are mostly plain areas, right? So 95%, right? There's a lot of mass over here. These are all plain areas, right? So this way, there's a lot of such analysis that you can do, right? You can study that how the cropping intensity changes with water balance, right? So you see an inverse relationship, or how cropping intensity changes with surface water availability. Yeah. So how much water is available during Rabi and how it relates to your cropping intensity, right? So a lot of this analysis becomes very easy to do. Yeah. Then after that, this blog will help you understand how we derive these micro watershed boundaries, right? So there's a particular process of doing that, that all of India is broken up into river basins, sub basins are broken up into watersheds, watersheds into micro watersheds of this sort. And then in each micro watershed, this is pretty much the size of a village. Yeah. So in each micro watershed, then we compute all of those properties, right, of cropping intensity and time series of cropping intensity, right? So a lot of that is what comes from these things. Yeah. So yeah. Then we had also built a bunch of demos of interesting interactive applications that you can also do, right? So here we did something that if you're interested in a particular area, right? You want to do something in this particular area. You then also want to know the flow of water, that which micro watersheds are flowing into which other micro watershed that is flowing into some areas of your interest. And if you do something in your areas of interest, then what downstream micro watersheds will also get affected, right? So these kind of interactive maps can be done, and these maps can be auto-populated with data that's already been computed. So like in this micro watershed, we are seeing that surface water availability has been continuously declining over the years. Yeah. And there is also a lot of deforestation happening. So there's a lot of forest area that got converted to farming areas. Yeah. And then other things like what is the rainfall in these areas? What is the runoff in these areas? Right. So a lot of these are data points which are already available. Yeah. This links to the micro watershed report, which uh, gives you even more detailed data points. It takes a couple of seconds to load. So this micro watershed report also tells you that for this area, right, what's the terrain like, some statistics, right? Which areas have cropping areas that have converted to shrub and scrub, like over here, cropping areas converted to built up, like over here, right? So there's a lot of these things, cropping intensity changes over the years and so on. Yeah. Surface water availability that in these kind of water bodies. Yeah. So in these water bodies, for example, how much area has perennial water, how much area has water up to post monsoon, how much area has water only during the monsoon, right? So all of these things are available, right? So you should go through these to really understand um, what is the core of all of this work that we've been doing. Yeah. Um, so the main agenda for today was to uh, just hear from you any particular problems you're facing. And then we wanted to talk you through some ideas that we had proposed for the challenge, as well as some ideas that actually communities have other partners have proposed, right? So I'll also quickly describe some three ideas that have come from other people, other organizations. Yeah. So any questions at this point?
No, sir, nothing yet.
Okay, great. So right, so this is the main challenge document, right? That talks about some of these things: who should participate, how to make your submissions, and so on. Um, and then let's go through some of these examples. Yeah. So here are just some ideas that you can start with, right? Bring boundary flexibility, right? So here, CoStack provides analytics at the micro watershed level by default, right? Like we were seeing that all of these analytics that we are computing are at the level of micro watersheds. Yeah. So that in different micro watersheds, right? So like in this, all of these different micro watershed units, right? How much area is under trees and so on, right? And likewise, rainfall, evapotranspiration, all sorts of time series have been computed on these micro watershed units, right? But actually, what people also want is actually uh, computations on village units, right? So all the boundaries are here, right? So instead of micro watersheds, they want that these computations should be done on the village boundary, Yeah. Uh, right. That in right on these boundaries, similarly, what are some of the uh, data points to, I mean, the same data points to bring about, right? So this is something that one of the things that we proposed that can we write simple utilities, yeah, that for a given village polygon, use the underlying LULC rasters over the years to compute and visualize how cropping intensity has changed over the years. Provide stacked area or stacked bar graphs and a downloadable CSV with annual areas. Yeah. So what you can, the way you can solve these kind of things is that right now I was showing you these rasters on Earth Engine. Yeah. But the same rasters are also available to you for direct download. Yeah. So if you use uh, the CoStack APIs, yeah, CoStack APIs that you can raise an API that tell me for this tehsil, tell me give me all the layers that have been generated, right? So like drainage, this is a layer, you can download it from in this way. Yeah. Um, it's also available on Earth Engine. You can download the Earth Engine layer from this. If you want to do the processing using Google Earth Engine, you can use the asset path that's given over here. But you can also do the processing locally using libraries like raster.io or GDAL, and you can download the layers from here. You can get the layer information through the APIs. APIs will return you this JSON object. Yeah. And these JSON objects will have other things, right? So like this is LULC, drainage, uh, restoration, right? Change detection, and so on. Yeah, right. So you can get this kind of information uh, from the APIs. Yeah, and you can download the rasters or GeoJSONs locally. Yeah. Um, Okay, right. So the APIs themselves, again, all the links are given, but the APIs themselves are also uh, published. Yeah. So these dataset APIs, for example, right, get generated layer URLs, right? So you raise this API that for a state district tehsil, you raise this API and this will return to you the output that I was just showing. Yeah, that what are the different layers and everything that you have. Yeah, right. So once you have that, then you can write your utilities that either download the rasters locally and vectors locally and do your computation, right? Or you can also, of course, invoke APIs on Google Earth Engine, right? Both both the paths are given. The paths to the Google Earth Engine asset, which has this data, is also given, and the paths to the path that you can through which you can download the raster is also given. Yeah. So, right, for the same village, compute seasonal surface water availability, right? Identify areas within a village that lost tree cover over a chosen period and estimate hectares of degraded land, right? And so on, right? More generally, combine all of the above and describe the most important changes the village has seen over the years and stitch it into a data story, right? So, so computing is one part. You can also then take it further. That can you also um, think about some nice visualizations or even some right template driven story format that you can put this in, right? So if, for example, a village has seen degradation, then you can start uh, uh, writing about right how much area has degraded. Perhaps you can also uh, you do some agentic AI work to also pull other information. Let's say somebody has might have published a news about the village, right? You can launch APIs to see if that village has been in the news related to degradation and pull in that news story, right? So that could become a very nice way of combining data that you can get from right the CoStack satellite data sets and everything that we process with some news that might have come about. Yeah. So this is one kind of stuff, right? That right, people want to compute not just on micro watersheds that we've done by default, but on other boundaries, right? But the data is there, so you can use the data to do the same computation. Yeah,
Can I ask a
yeah,
question?
yeah, yeah,
Okay, so the raster data files are very huge in general. So can we get a few test files to
yeah.
test it on, like village level or district level or micro watershed level?
Yeah, yeah. So actually, these files, that is why we are publishing these files on a tehsil level. So these
Okay.
rasters are actually not very big. They are just a couple of MBs actually. Yeah.
Okay,
So you
thank you.
do, yeah, you don't have to work on the full pan India raster.
Yeah,
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 exactly. So be careful. That's a good question. That on this Earth Engine application, we've also given links to these assets. And here, for example, for the rasters, right? We've also uh, these are published on Earth Engine, right? So this is the asset path on Earth Engine for the whole pan India. This is the raster file, which is also pan India. Yeah, but these are very large, right? 7 GB, 6 GB, and so on. So these are pan India, right? Don't use these for your local processing. Yeah. If you're working on Earth Engine, use the Earth Engine path. I mean, use the Earth Engine asset because Earth Engine has all of it spatially indexed and you'll be able to use it easily. Or if you're doing it locally, yeah, then use the layers, the raster paths that have been returned in these APIs because these are small rasters. They are basically the same pan India raster, which is like 7 GB, but clipped to a tehsil. So it's just a couple of MPs over here.
yeah, thank you.
Yeah. Uh, Great. So then a bunch of ideas we suggested were problems that need composition of multiple layers, right? So let's look at some examples, right? Rank micro watersheds in a tehsil by sensitivity of cropping to drought. Yeah. Yeah. So now, how do we do that, right? So now, sensitivity of cropping to drought. So in these APIs, um, what we provide, one of the APIs get tehsil data, right? So one of these APIs, which is get tehsil data, or yeah, yeah. So this one that for a given state, district, tehsil, this API returns you a list of uh, all micro watersheds and a whole bunch of properties about that micro watershed. Yeah. Now, among these properties, what you are also getting is your uh, drought incidence. I've forgotten in which one that comes. Aman, Shiv, if you remember, maybe in this one. Yeah, right. So here we've computed for you, right, that in which micro watershed ID um, uh, out of so many weeks of Kharif, how many were drought weeks? Yeah. So, right. How many weeks had mild drought, moderate drought, or severe drought? And how many weeks of dry spell were there? Yeah. In 2017, right? Similarly for 2018, yeah, for it's a right, you'll have to order it a little bit yourself because this ordering may not be very consistent. This is something we need to work on. But for total, like in 2018, total weeks of Kharif season, how many weeks had no drought? How many weeks had mild drought? How many weeks had moderate? How many weeks had severe drought? And how many weeks of dry spell also, right? So this thing helps us understand uh, which were how significant, how severe was a drought in a given micro watershed. Yeah. Now, a drought is also defined as number of moderate plus severe weeks being greater than equal to 5, right? So that's what the government of India uses as a definition. That if and moderate and severe itself is defined internally in terms of the various metrics of whether the rainfall is much lesser than what it was over the average of the last 30 years and so on, right? So without getting into that stuff, ultimately, this can help us understand that if your number of moderate plus severe weeks were greater than equal to 5, then you say that microwatershed drought in that year. Yeah. Now, when a drought happens, what would it do? Well, perhaps the cropping will get affected. So this cropping intensity then tells us um, that in this year, 1718, yeah, in the year 1718, how much area was single cropped, how much area was double cropped, how much area was triple cropped, right? Double crop meaning there were two crops in a year, triple crop meaning there were three crops in a year, yeah. But if some year was a drought year, yeah, right? Let's say if 2020 was a drought year, then what you might notice is that the single cropped area in 2020, yeah, so many hectares would be less than the single cropped area in non-drought years. Yeah. In fact, you can see that it is varying, that in 2021, so many was 247 was single crop, but in 1819, 337 was single crop, right? So more cropping happened over here. Yeah. Now, potentially, this could be because maybe this year, 2020, may have had a drought. Yeah. Um, right. Actually, I forgot the micro watershed, but again, these are all neighbors. Uh, yeah. So, and yeah, I mean, there are, right? I mean, mild, actually, yeah, it's just mild drought. But anyway, yeah. So this is what you can see, that all the data is there. So can you actually do something like this? Yeah. Compare the cropping intensity during identified drought years versus non-drought years. Yeah. That was the cropping intensity during drought years and what is it during non-drought years. If there is a big gap, it means that this area is very sensitive to drought. The cropping is very sensitive to drought. Yeah. And can we use it to rank these micro watersheds? So now in a tehsil, there'll be about 100, 200 such micro watersheds. And we can develop a ranking. And this ranking can be used to prioritize that, okay, these micro watersheds are more sensitive and perhaps some kind of drought proofing should be done over here in priority. Yeah. Drought proofing can be done through constructing check dams and farm ponds, right? So that if there is a drought during monsoons, then these kind of structures can be used for getting water. Yeah. So that is the idea that, yeah, that you can write utilities of this sort, that for any given tehsil, so it can be a very useful input for planners, that which areas are seeing more sensitivity to drought. Yeah. Find the top 5 microwatersheds most similar to a reference microwatershed based on terrain, drought frequency, and land use. Yeah. So this is again quite interesting, right? That now all these microwatersheds, like we saw, they all have different values to these properties. Yeah. So so terrain, right? So in terrain, for example, we have computed things like how much area in this microwatershed, how much percentage area is plain, how much is under ridges, slopes, valleys, and so on, right? Yeah. So, right. So now you can say that, okay, find me other microwatersheds which are kind of similar. Yeah. So you can now think about creating a distance function where you're basically saying percent area in this microwatershed under plane minus percent area in the other microwatershed, which is plane. Yeah. And similarly, difference in ridge, difference in slopes. Yeah. And you can then come up with a score of that for any micro watershed, which other micro watersheds have a similar terrain. Yeah. You can, of course, do other things also. You can do a clustering, for example, right? And you'll see that, okay, these micro watersheds are of one type and these are of another type. In fact, that's what we do. So this thing called mostly planes, it's actually coming from that there are a bunch of micro watersheds which will be mostly plane. Yeah. Like this one, right? The percentages here, mostly plain, are similar to the percentages here, mostly plain. So a lot of these micro watersheds belong to the same type called mostly plains and which we derive through clustering. Similarly, a, a lot of these, right? Which we are saying that they have a mix of plains and slopes. So a lot of these percentages are similar in microwatersheds labeled as broad plains and slopes. Yeah, broad plains and slopes, right? So these percentages are kind of similar. Yeah. So that's what we're saying, that can we find for any microwatershed, can we find other similar ones? And similar in terms of what? Maybe in terms of terrain, maybe also why not in terms of drought frequency, that okay, the terrain is similar, the drought occurrence is also similar, and land use is also similar. Yeah, that percentage of area which is built up or under trees or under crops, that is also similar. Yeah. And then what you can do is you now know that, okay, these microwatersheds are all quite similar in terms of external influences. That terrain is what, they have. God gave them that terrain and that's what they have. Drought frequency is what they have, right? Whatever rain is coming, they are not influencing, right? But it is what it is. Land use is what they have done, but again, they're not going to be able to change land use in any way. Yeah, how much area is under trees and so on, right? But in all of these, maybe there is a difference in how they are doing cropping. Yeah, maybe some of these microwatersheds are more intensely cropped. Some have more water than others. Some have a different water balance than others. Yeah. So can we use this to identify microwatersheds that are positive deviants in their tehsil? Yeah. Positive deviants meaning that, let's say, of all these plain microwatersheds, right? Let's say if you just do it on terrain, right? All these microwatersheds which are mostly plain, can we find which ones of them have a good water balance and also good water availability? Yeah. And also high cropping intensity. Right. So what that would mean is that that's why these microwatersheds are called positive deviants, that there's something going on with them, right? That the community is doing something, maybe they are maintaining their water structures nicely, or they have created a lot of water structures. There is some secret sauce over there, which is why these microwatersheds, even though they're similar to so many other ones, are doing quite well. Yeah, that's what we mean by positive deviants. Yeah, and are worth investigating further on what practices the local communities could be using to do a better socio-ecological position as compared to other ones. Yeah. So again, this can be a useful utility for any planner, that they're seeing that, well, so many microwatersheds are sensitive to drought, but some of them, they're all quite similar, but some of them are doing a much better job than others, right? How is that possible, right? So maybe they can go and investigate, right? What is it that the communities are doing over there, right? That's the idea here. Yeah. For each migration in a tehsil, position them in a 4-quadrant classification using mean cropping intensity and mean runoff. Yeah. Yeah. So meaning on one axis you have cropping intensity, on the other axis you have runoff. Yeah, this can potentially have identified priority microwatersheds for sustainable cropping intensification. Yeah, what does this mean? Quite a mouthful. What this means is that microwatersheds which have a low cropping intensity, right? Not a lot of area is being cropped. Yeah, but there is high runoff, meaning that when it rains, a lot of water runs away. Yeah, but they are not doing a lot of cropping. So sustainable intensification means that how do you intensify cropping intensity, but in a sustainable way? Sustainable way is that if there is a lot of surplus runoff, then by constructing check dams and trench cum bunds and so on, you reduce the runoff. You keep the water in the micro watershed and you use it to fill up your farm ponds. You use it to recharge wells so that you can do more cropping. Yeah, you can increase your cropping intensity. That's sustainable. What might be unsustainable is that you let the runoff drain away, but you start pumping groundwater. Yeah. So groundwater has whatever, stock of groundwater there is, and you can keep pumping. Yeah. You'll also intensify your cropping. Yeah. You'll intensify your cropping, but you're not recharging that water. So it is not sustainable. Yeah. So you're taking away, and eventually the aquifers will deplete, and which is what has happened in many parts of India. Yeah. So that is unsustainable cropping intensification. But sustainable cropping intensification can be if you tap the runoff. Yeah. So this kind of a quadrant where you find out areas which have a low cropping intensity, but significant surplus runoff. Yeah. These could benefit from rainwater harvesting structures. Yeah. So again, it's about giving precise policy advice that you can exactly say that, okay, these areas are where you want more rainwater harvesting to be happening. Yeah. These are areas where you want some drought proofing to be happening. These are areas where you need to investigate what is it that the community is doing? What secret have they figured out, right? That they're able to manage their resources much better. Yeah. So that's the idea. Yeah. And pretty much all the data points that you need, it's all there. Yeah. Uh, in a tehsil, compare percentage SC/ST population of a village against the number of Narega works done in the village. Right. Visualize potential marginalized villages where Narega is not very actively used. Yeah. Narrow this down further by prioritizing areas that are drought stressed or have degraded in recent years, where appropriate Narega and other interventions can benefit the communities. Yeah. So all of this analysis is telling us which areas need, treatment, need farm ponds, check dams, other types of structures, trench bunds, and so on. Yeah. Right. So you identify the need. These are areas that really need those things. But are we providing them in those areas? Yeah. So right. So these APIs basically also return you things of the sort. Uh, there is this Nareka annual, is it? Yeah. So in each year, in this micro watershed, in this year, how many soil and water conservation works were done, how many land restoration works were done, and so on, right? So a lot of this information is there. Yeah. I'm just mostly seeing zeros, but it depends on where I click, right? Um, in this micro watershed report, or maybe I closed it. Yeah. So in the micro watershed reports, which you can explore through this interface, right? Uh, right. If you go to any state district tehsil, you click somewhere and yeah, click on and you see the micro watershed report. Yeah, and this thing is picking up data through the same APIs. Yeah, that we're talking about over here. So this thing tells you, right, that in that tehsil, this is what I had brought up earlier, but towards the end, you also have this information that what are the villages that intersect with this micro watershed? What is their SC/ST population distribution? What kind of Narega works have happened over there, right? So soil and water conservation, land restoration, and so on. Yeah. So that's the idea. That now what you can also do is that now from this kind of analysis, you know what's needed where. Yeah. But you can also use this to see what's actually being provided. Yeah. And you can find the gap. Yeah. That that areas which are drought stressed or have degraded in recent years, where Narega can help, but maybe it's not being done, right? So again, right, very precise policy advisory, right? That in these villages, you need to fund this thing more. Yeah. All of that can be done. Yeah. Then there's a bunch of ideas around external data. Yeah. So all of these ones are what you can do using data that's already there. But of course, right, we've not processed everything. There's a long list of more things that we can do. Yeah. But for example, you can you can use other APIs to find APMC mandis, right? The agriculture commodity mandis. Yeah. Analyze whether proximity to markets correlates with cropping intensity. Yeah. Um, Meaning to say that areas, right, you can expect, right, that if areas which are closer to mandis, what will happen is a positive feedback loop will typically set in, that farmers will be able to sell in the mandi more easily. They'll get more money. They'll use the money to do more cropping, right? To buy bore wells, to, right, or move to cash crops and so on, right? Right, so that which is called commercialization of agriculture, right? So likely you're able to you're likely to see that areas which are closer to mandis are more commercialized, yeah. But you can actually check that in the data, yeah. Yeah. How do you get these APMC mandis? So if you can, right, that will be a good contribution also to build this data set. But actually, there's a simple way. It's just that somebody has to do it. Uh, okay, I may not exactly find it so quickly. Uh, Uh, but there is an agri-census website, and I think if you browse somewhere on this website, you'll yeah, I won't get it right away. But basically, there is a drop down. Yeah, and you can scrape the drop down, which lists all these APMC mandis, and you can send the name of the mandi to Google Places API. Google Places API will give you the latitude longitude of the APMC mandi. Yeah, and once you have the lat long, then that's all that you need, right? Then you can see which areas around it and so on are doing how is the cropping changing around it. Yeah. So this is one way in which you can, right, use external data. Yeah. Then similarly, CoStack itself provides many datasets which have not been integrated into APIs. For example, the connectivity graph of microwatersheds. So this is actually the same thing that I showed over here. This thing that I had showed earlier of how all of these micro watersheds are connected into other micro watersheds. This is actually coming in from these right? There is a asset we've created over here uh, on uh, connectivity, micro watershed connectivity. So what this actually tracks for you, right? Actually, this is not so good a visualization. Um, but what this is saying is that, these arrows where they are intersecting, um, maybe this one isn't clickable, is it? Okay. Yeah. So these arrows are actually, I don't know if it'll, yeah, I probably don't have it. Maybe it'll work. This is just from last time. That's what happens on these connectivity points is that in this, you actually have information that for this micro watershed, what is the downstream micro watershed? Where is it flowing into? And a list of upstream micro watersheds. So this one is actually doesn't have any parents because this one is right at the head. But let's say, oops, you uh, go somewhere else. You'll uh, see one. Okay, this one also doesn't have any upstream. But anyway, right, you get the point, right? That basically this particular starter kit, right, if you go deeper into it, you'll see how you can call this, use this MWS connectivity asset to see for which microwatershed, which is a downstream microwatershed and what is the list of upstream microwatersheds. So that is what was used to construct these arrows, basically, right? That this one flows into this flows into this also flows into this, and so on. Yeah, all of these flow over here. So yeah, so that's the idea that you can do something fancy with this micro watershed thing, recent global data sets on natural forests. So there's a lot of such ideas over here, yeah, that you can do, yeah, um, right. But let me also come to um, ideas that our partners have suggested. Yeah. Any questions on any of this so far? Okay, then let me keep going. Yeah. So here are some other nice ideas. Yeah. which partners have proposed, and these ones are slightly longer projects. Yeah. So in fact, so with the challenge also, we've extended the deadline up to the 15th, but then we'll also have like quarterly, right? So this doesn't end on the 15th, right? You should continue to remain engaged, and we'll keep going. Yeah. Many of these ideas over here are what, these are the kind of things that you can think about. Right? There's a lot of links to resources, evaluation criteria, some other ideas of writing tools and so on, right? So go through these. These ones are what you can do very quickly. Yeah. These other ideas are slightly more researchish, right? So this idea by INREM, so what INREM has proposed is to build water quality maps. Yeah. So water quality is something that we've not integrated into the core stack as yet. Yeah. But there are several national level data sets, and INREM actually specializes in this. They do a lot of water testing on the ground. Yeah. Of water bodies, of wells, and so on. And they come back with reports of where is there arsenic excess, fluoride excess, or industrial waste that might be causing water pollution. Um, so there's a lot of interesting ideas here that now what you have through these are basically point measurements, yeah, that of a particular point where there is some water issue, another point where there is some other water measurement, another point where there is some water measurement that has been done, yeah. But how do you combine them together into one kind of a map, yeah? So one simple way, of course, is to assume some sort of spatial correlation and to do interpolation, right? That areas where no measurement has been done, you can say the arsenic content in that area would be the average of the arsenic content measured in some neighboring points. Yeah. That's so there are some ways around called methods called kriging that can be done for that. Yeah. But you can actually do some more interesting things. Yeah. Um, right? That one is well, okay. Let's say you do just an average, yeah. But then what you can do is that you can use other layers which are there on the core stack to say that which areas are good for groundwater recharge. So now you can imagine that if some area has some salinity problem, yeah, one of the ways to tackle salinity is to create more fresh water on top of it, so that when you're pumping water, you start pumping more fresh water rather than the more saline water in the deeper aquifers. So so what this can help do is that if the specific problem you want to solve is saline groundwater, then it can help you identify areas where you should do more of groundwater recharge from rainfall. Yeah. So that's right. One of the things, right? You can also use some settlement characteristics like population, right? And other things like roads and so on to further prioritize which areas might be better. Yeah. So these are some of the ideas that have been proposed. Then similarly, one other interesting idea is aquifer delineation. So if you're getting if you're measuring groundwater quality and you're getting the similar measurements in a bunch of different places, then you can imagine that probably the underlying aquifer is connected, right? That the groundwater is flowing between these areas, and that is why they have a similar chemical composition. So that can actually be quite useful for aquifer mapping, which otherwise is a very difficult process because you actually have to drill bores into the ground and then do rock analysis, the chemical composition of the rocks and so on to see whether it is one connected aquifer or not. Yeah. And you have to do other things like pumping tests where you pump out water and you use that to figure out how the aquifers are connected to each other. Yeah. So, right. So some of it can be used for that purpose as well. Yeah. Then, yeah. Um, yeah, similarly, right? Public health risk scores, right? Can also be created through all of this, right? So again, can be quite useful to uh, identify which areas might need some priority treatment. Yeah. So there is a lot of such, right. So Sundar from INREM and their team, right. So if you're interested in something like this for a longer term project, right, then this is also something quite interesting. Yeah. Another idea is from Kaustubh, who's a professor at Azim Premji University. So Kaustubh has been maintaining this website called the Tanks of Anikal. So these tanks of Anikal are basically, Anikal is in urban Bangalore, where there is a lot of water tanks, right, which are all connected with each other. Yeah. Um, uh, and Kaustav has been maintaining information about a bunch of things, right? One is ownership records, right? That because one problem that urban lakes and everything face is encroachment. That community is staying over here, right? They would build a house or they would build a platform or something, right? And they try to get land and so on, right? That's one problem. Another is there might be some construction happening on these drainage lines. Yeah, because otherwise when it rains the water kind of first collects here, then it flows down, then it collects over here and so on, right? And that is actually very useful for actually it's the other way, it goes this way and then it's going into this river. Yeah. um, but this is very important for flood handling, flood mitigation, right? Because it is when these channels get blocked that then the water over here has nowhere to go, then it sort of stays here and you get waterlogging. But if the water can flow from here to here, from here to here, then it's much easier to deal with the flood situation. So Kaustav has been maintaining information on water body boundaries, um, and also most interestingly on biodiversity. Yeah, that they regularly do visits of these water bodies and they document which birds and so on are over here. So we have actually, right? So now, I mean, that's one example. But if you've seen some of this water body data, then um, right in Anikal over here, if you turn on this water body layer, it will take a couple of seconds. Okay, it came up very quickly. Yeah. And right, so these are those tanks that Kaustav is interested in studying, right? And if you go somewhere, right, you open the water body profile of that tank, right? So this profile then tells you in different years how much of this tank had water throughout the year, how much of it had water only during the monsoons, right? So all of this kind of a dashboard is what we've populated using remote sensing, right? What kind of cropping is happening in its neighborhood, right? So some kind of cropping seems to be happening here, uh, right? How has it changed over the years? Single, double, triple cropping, right? Drought incidence, right? Where is it situated with respect to the rest of the setup, right? Now, all of this can actually be enriched. Yeah. So, what we've proposed over here is that can we augment, right, the core stack, this kind of a water body dashboard, so that folks like Kaustav have all of this information readily available on their fingertips. So, can we augment this with biodiversity information? And where do we get that? So actually, if you know about eBird, so eBird is a citizen science application which people use to document bird sightings. And eBird already has a lot of APIs. So what you can do is that um, for every water body, right, find an eBird hotspot on which people have already been documenting bird occurrences and use APIs to get that information from eBird. Yeah. And it can be layered over here, right? So there can be a similar, right? Just like we have a section on largely, we were looking at water availability and use of water body for cropping, but that's not the only point, right? Water bodies are also important for biodiversity. So that's what can be done over here, right? So uh, augment it with biodiversity information from citizen science initiatives like eBird and iNaturalist. Yeah. Um, then other ideas can also be done, right? That you can use data collection tools also, so that for people like Kaustav, it's easier to build dashboards that they go and they collect information, they document the biodiversity and other things, right? Any encroachments or anything that they're noticing. They do it once or twice a year. Yeah. But we can actually give them an app so that when they're doing this, they have one place to collect this information more systematically. Yeah. And all of that can be shown on these kind of maps. Yeah. So that's another uh, idea that we can work on. Yeah. Yeah. A third idea, which just came today from Madhura from Wildlife Conservation Trust, is about finding command areas of reservoirs. Yeah. So yeah, let's see if something happens here. So reservoirs, as you know, are basically created behind dams. Yeah. So again, we have put up a lot of these data sets together. So we sort of, right, know where are all these reservoirs, right, which typically have dams behind them. And we also have the canal network. Yeah. So command area is, so now you can see that there are all these canals emerging from these reservoirs, right? Okay, so this one is, I've actually been here. This is an amazing, this is Bull Rock near Jabalpur. Um, so this is a dam. These are canals coming from the dams, right? These are canals and their distributaries and so on. Yeah. Command area is which areas are using this irrigation water, right? And which areas are not using irrigation water. Yeah. So what you can do is you can use this, you can intersect which canals are intersecting with this, and you can trace the canal because they might be stored as multiple objects. So this might be one object, this might be another object, this might be a third object, but you can build a graph of all of this. And then you can see that in, let's say, 100, 200-meter buffer around them, yeah, we can in fact do it like, we can in fact do this, yeah. So actually we should have, yeah, these are some limitations. We need the LULC layer to be loaded first. Yeah. Uh, okay, let's try doing this. So yeah, let's clear. If this doesn't have bugs, then this should work. Now load the LULC. Yeah. Now load your uh, uh, reservoirs and load your canals. Yeah. Now something to check is if around these canal areas, right? So actually it's interesting. We are not seeing much of a difference. Yeah. But potentially the idea to now check is that around these canal areas, in some buffer around the canal areas, is the cropping intensity higher than areas which are away from the canals? Yeah. Or areas which are to the head of the canal, right? Now, all of these areas would be getting water easily. Yeah. But areas which are further and further away, right, may not be. Yeah. Because it depends on, right, farmers at the head of the canals would typically have faster, quicker access to water. Farmers at the tail end may not, right? But a lot of this can be investigated. Yeah. So a lot of this can be investigated that um, how is cropping intensity around the canals different from cropping intensity in other areas, or right, potentially what kind of crops are being grown, um, how is does the cropping intensity change further down the canal versus upstream from the canal. So that's it's right, but right, computing this command area can be quite interesting. Yeah. Then there's some other ideas also over here around also looking at, because what also happens in these canals is that those which are unlined, the water also percolates into the ground and helps with groundwater recharge. Yeah. So it's not just that the flowing water is used to pump water in the neighborhood, but actually whatever water seeps in is also helping, yeah, wells and recharge wells and other water bodies further downstream. So there are ways in which you can get to those as well. Yeah. So these are some other ideas that we've also put up. Yeah. Yeah. So right. So let's so any questions at this point?
Are these canals using some shapefiles provided by government, or like we can infer canals also from LULC maps? Um,
Ah,
these are very precise. I mean,
yeah, yeah. No, good question. So these ones are actually canals shapefiles that we've downloaded from,
yeah,
and similarly reservoir shapefiles that we've downloaded, right, from what the government is providing. Yeah. Um, right. But that is another good question that now actually, if you see, you're not actually seeing, right? You see actually small dots. You do see some small dots of blue. Yeah. So the thing is that uh, the satellite pixel is basically a 10 meter by 10 meter pixel. Yeah.
yeah.
And that may not be enough to catch the water in the canal itself, right? So that's why we're not actually seeing a lot of water on the canal. Yeah. Um, yeah.
Yeah, merging this can we can do actually that head tail analysis, and that would
Yes.
be
Yeah. Yeah, exactly. So that'll be a very good kind of an exercise. So take the LULC, right? Take the canal boundary, which is basically a line, take some buffer around it, and then in that buffer, study these kinds of things, right? Water availability, or yeah, like over here we're seeing some stretch of blue pixels. So study water availability, study some of these other things on cropping patterns. Yeah. We're also seeing a lot of trees planted along the canals, right? So that's also interesting that, right, like over here, right? So there's a lot of tree cover around the canals. Right. So if you, let's say, turn this off, right, then you can see that there are these trees and the LULC is catching some of these trees. Yeah. Yeah. But some of it is also calling it triple cropping, which is not very accurate. Right. So yeah. But yeah, you get the point, right? See, over here the canal uh, is so wide. Yeah. And that's why the LULC is also catching some blue pixels.
yeah. We can use this shapefile actually to denoise the LULC also, like because of which it is showing three crops or multiple like different.
Yeah, yeah. I think that's a good idea. Yeah, I think, yeah, some of those things can be done. Yeah, yeah, totally. Yeah, yeah, yeah. I mean, I'm just looking at these maps and it's quite interesting, right? What is the structure? So these are, oh, maybe these are, uh, yeah. I mean, this is like this is what? This is a bridge or left bank canal, Bargi left
Underground or
bank.
something.
Yeah, I don't know. Yeah, I mean, this is the Narmada, this is the river, this is some rocky structure on it, on which the canal is actually flowing through a tunnel or something.
Yeah, yeah, that's what.
Yeah, yeah. So there's the canal is coming here. Then I didn't know that this is how this is done actually. So this is probably a tunnel. I mean, basically like a bridge over the river, but it's a tunnel kind of a bridge,
Hmm.
which takes it to the other side of the river. Yeah, quite interesting. Acha, the Narmada is here. This must be some tributary. Okay. Yeah. So, yeah, I mean, lots of, I think if we start looking at it, lots of interesting things can be done. Yeah. Yeah. Okay. Cool. Yeah. So, guys, other questions? Yeah. So, where's this thing go? Um, Sorry, are there some chat questions as well? Let me. The sharing has stopped. Okay. Uh, cool. Great. So, guys, basically, we do hope, right, that you'll submit some exciting entries. We have this deadline up to the 15th for the first round, but we'll keep this open throughout the year, and we'll do quarterly rolling deadlines. Um, we also have we'll be able to do some cash prizes of the order of 10,000 or so for some exciting solutions and ideas. Um, Force United is also a key partner and mentor in all of this, and they've also committed to doing some merch. I don't know what that includes. I guess t-shirts and some other nice goodies. But that's not the only thing, right? Like you've seen, right? We're building the core stack as a public infrastructure. Yeah. And there's a lot to do. Plus it's taking a unique kind of an approach of providing pre-computed data so that ecologists and everyone can do a lot more with it very quickly, rather than having to look at, generate the data and learn about how to do all this remote sensing data processing and everything, right? So, just for that purpose, right, to be able to contribute to building this public good, I hope you guys will be excited and you'll end up contributing. Um, yeah, so please, ask for any suggestions, any help you need. Uh, we're most happy to work closely with all of you. Yeah. So write on the chat, write on the Discord, write on the Google group. You can write to us directly. Yeah. So yeah, we can engage on all of that. Yeah. A question on how is LULC done? Yeah. So yeah, a lot of it is supervised classification. Um, so again, yeah, if you just search, right, but go through the CoStack website, but just search for technical manual course stack. Um, you'll you'll get the large manual, right? So this manual talks about how all of these data points are computed. So with LULC specifically, we actually use the spectral open satellites, Landsat and Sentinel, and their spectral bands. And a lot of it is supervised classification. Some classes we do in an unsupervised manner. Um, yeah. So this one has several details on how that's done. Yeah. Cool. Okay, guys. So, yes, thanks for, being there and wanting to participate and contribute. Yeah. So do reach out for anything. And yeah, look forward to seeing some exciting ideas coming out of this whole effort. Yeah. As you can see, it's not just this group which is building stuff. Now we have NGOs and partners giving ideas on what they need, right? That's really the kind of an ecosystem we want to build, right? That there are partners who are suggesting what kind of stuff they want, and then people like us who are doing computing and so on, we can help build all of it, right? So yeah, so hopefully, we'll keep catching on all of these ideas. Yeah. Okay, guys. So let's stop now, and yeah, do reach out for anything, and best wishes once more. Hope all of us have a great year ahead. Yeah. You can stop the recording.